So we're going to cover exactly what the Michaelis-Menten graph looks like, what the graph tells us, and how we can identify the Km and the Vmax on this graph when we're looking at it. So we can start here and say that it shows us the enzyme activity and the rate of reaction on this graph. And this is at different points in time throughout the reaction. And this is based off the steepness of the graph, how high the graph goes, etc. And can tell us information about the enzyme activity, as I said. So different enzymes will have different effects on this. And we can also use this graph as well to have a look at identifying the Km and the Vmax, as we mentioned earlier. And we'll find out in a minute what these both mean. And it is actually really simple once you get your head around it. So make sure you watch to the end to find out how this works. And it's also, this Michaelis-Menten graph is what we call a hyperbolic graph. And this is essentially the shape that we get, and you'll see this in a minute. So I'm going to go ahead and draw the graph out here. These are going to be the axes for the Michaelis-Menten graph. So on the y-axis, we're going to have the velocity, and on the x-axis, we'll have the substrate concentration. So as you can see, I've drawn in my curve here. This is going to be the plots that we'd have from the reaction, and it gives us this nice smooth curve. And this shape here is what the hyperbolic graph is. That's the name we give for this shape. So we're going to say this first region here is going to be called the first order. And basically this means that increase in the substrate concentration has an increased effect on the rate, which is directly proportional to that increase in substrate concentration. Then we have that intermediate region there, which is before it flattens out. And then when the graph plateaus at the top here, we call it zero order. And this is where when we increase the substrate concentration, it has no effect at all on the rate of reaction. So it's flat. So we can go and say that this top point here where we reach zero order and it plateaus is the Vmax. And this essentially is when the maximum velocity of this reaction has been reached. So we can draw this line to the very top of the graph. And I'm going to quickly say what Km means, and this means the half of the Vmax. And Km essentially is the affinity between the enzyme and the substrate. So basically how strong these two complementary molecules fit together. So here you can see I've drawn Km, which is halfway down the y-axis, and then we meet it on the x-axis here. This is the Km. And of course, a lower Km is going to mean that the affinity is higher. So if we have a reaction that looks like this, where I've drawn this red line, which we can clearly see is more vigorous and has a faster rate of reaction, this is going to have a smaller Km, as you can see, where I've drawn Km2. And this is because there's a higher affinity between the enzyme and the substrate, which means the substrate is binding into the active site much more strongly in this second reaction. So as you can see, I'm writing out here, the enzyme fits much, much better. So it's more complementary. That's what the affinity means, essentially. And of course, don't forget the key part with enzymes is that these substrates bind to the active site to form the enzyme substrate complex. You can see this in my overall enzyme video. So hopefully that makes it really simple. Thank you.